add, well, the velocities don't add, but rapidities do. Rapidities add is the result, and that's part of the reason that you're interested in it, physically speaking. Also, it's just a useful mathematical description of the Lorentz transformation, like that. All right. Yep.
So we mainly been talking about like physical things.
I'm sorry?
We've mainly been talking about like physical things like a ball being thrown or a bullet.
Yeah.
Do the same things apply for like waves or sound?
Well, sound is group physical motion of air particles. So, I mean, you'd have to first give me a mechanical description of sound, and then I guess, yeah, two inertial observers could compare how the story goes. I mean, I don't know. All right. Okay. So I'm getting somewhere, guys. Believe it or not. So space-time diagrams are really important to understand these things a little bit better. And so the idea is simply this. We only can get so far with these Lorentz transformations. I mean, you kind of get lost in the equation. Sometimes it's nice to have a picture of things. So the idea is this. We graph time vertically, and we graph space that way. All right? And then pick a moving frame with a certain velocity, right? And you can study like the t prime. Let's see here. So we have what? T prime. How's it go? Gamma. Let's say ct prime. Oh, stink. Fine. I can never make up my mind whether to work with x naught or with t. Let's see here. What would the equation of the t prime axis be? What's the equation of the x-axis in xt? It's just t equals to 0, right? The equation of the t-axis is x equals to 0. The equation of the t prime axis, which I have not yet drawn, is x prime equals to 0, right? X prime equal to 0 is what, though? X prime equals 0 is gamma times x minus ut, right? In other words, it's x is equal to ut, or in this case, t is equal to what? 1 over u times x. There is the equation of the t prime axis. Now, I'm actually thinking about, I mean, to be honest, I'm putting x naught up here. Okay, fine. I mean, it's ct. That's the scaling I'm using, because, so like, if you had velocity c, it would have slope 1 in this picture, right? If x if x over ct is equal to 1, that would be speed of light. I mean, so this is a slope. U has to be less than c, right? U has to be less than c. And so what's that mean? That means that 1 over u is what? Right? So again, slope c, fine, if I multiply this by ct, what do I have? Ct, c over u, right? So c over u is what? Greater than 1. So my point is simply this. T prime has to look something like this. That's the t prime axis. And symmetrically so, x prime is down here like this. Something like that. you can get x prime from just putting what? Put t prime equal to 0, right? Put t prime equal to 0 here, right? What's that give us? T equals to ux over c squared. And then that gives me what? I've got u over, my slope is u over c squared, right? Since u is less than c, that definitely is what? That's smaller, it slopes smaller than 1. So it looks like this. Now what you do is you draw lines which illustrate same position or same time in the moving frame, right? Now notice the horizontal lines and the vertical lines, they illustrate same time or same position in the S frame, in the rest frame, right? But now we have this one picture. Once I draw these new lines, I'll draw them like so. These are supposed to be parallel. I tried. That's sad. Oh well. Those are supposed to be equally spaced t prime. Well, those are x. These are these are the positive. Fine, I'll make it a different color. See it better. And then also I should draw equal time prime time lines. Like, let's see here, I'll use blue. Oh, I use blue. I don't know, pink, whatever. So. All right, so these, well, one of them, right? All points at same t prime. These ones, all points at same x prime. So this picture, it gives us a way of comparing events. All right? Check this out. If I take this point up here, all right, that would be, let's say that this is B. All right? And, oh, I'm sorry. Give me a second here, I'll figure it out. Something I'm trying to do here. See, suppose I have this event versus that event. No. Oh man. All right, so this comes out to time TA A. All right, well, I've got, let me follow my notes here. I've got event A, event B. They're both happening at x prime equal to 0 along the t prime axis, all right? I've got another event over here, event C, like that. And I wanted to look at an event like over here. Maybe my picture is just not quite far enough. That's my problem. So I'm trying to find, I mean, if you look at it, you can eventually get an event D oh man. Like this. Now what I'm trying to get at here, guys, is I think we can all agree that TA prime, right, is less than TB prime, right? I mean, this time is before that time in the prime time axis, right? And you can also agree, see? So like here is TB, and here's TA, right? And you can also agree that TA is less than TB. That's good, right? If event A comes before event B in the prime frame, then event A should come before event B in the what? In the unprime frame, right? What's the deal with events C and D, though? See if I did this better. Oh man, my pictures stink. Sorry, let me see. Oh, maybe it's already. So how about TC? Now I think we can all agree that TC is equal to what? TC prime is what? The time in the prime frame for C is TA, right? The time in the prime frame for D is what? TB. And what's the deal if you go over here, though, and look at the time? You're like, you should look at the time. Be nice. I got stuck earlier. Come on, guys. I think you can see that TD is less than TC, right? So what's that say? That says that D before C in S frame, right? But what do we have about TC? This, that gives, what do I have? I have A is less than B, right? So I have TC prime is less than TD prime, right? Uh-oh. This says that C is before D in the S prime frame. So this could be very troubling, right? Like if D is like the event of you being born, or no, let's say D is the event of your grandmother being born, and then like C is the event of you being born. This is very troubling because like in one frame of reference you're born before your grandmother, and then in the other frame of reference your grandmother's born before you. It doesn't seem like that can possibly make sense, no matter how many equations I solve in junk, right? In other words, what's that? Oh, okay. This is a problem. This is what I'm describing to you is violating causality. The ordering of events. But then again, this is what the space-time diagram has revealed to us. It's possible. Here's the catch. It is impossible for event D and event C to be causally connected. The fastest you can go, and this is why the speed of light has to be the speed limit. Because if the speed of light wasn't the speed limit, then the paradox I'm describing would be a real physical possibility. Event D could affect event C, and vice versa, and you would have the trouble of killing your own grandmother and such, which you shouldn't do. The point is, in this, if you pick any point on this diagram, like this one, that event, the things which it can be connected to and affect are within what's called its light cone. These points in space-time are the only ones which can be causally connected to this central point, because only inside the locus of these two asymptotes do you have points which are reached to the central point by trajectories which are going less than the speed of light. So this points D and C that we got the paradox for simply cannot cause. There's no cause and effect between these points, and so the paradox is resolved. And it's also why it's a very big deal to say something's going faster than the speed of light, because if you can, this is how the time travel happens. that thing I was talking about, like that is actually a picture to describe it. Anyway, I think I'd like to talk about 4 vectors another day. If you don't mind, that means that I'm going to push something off the syllabus, like the thing that's beyond springs, waves, it's gone. I'll leave it in the WebAssign. Those are bonus problems, but I won't test on them. If that's okay. Thanks, guys. Sorry about the unfortunate length contraction debacle.